So we have next we have composite bodies. Some people will say composite bodies. Composite bodies are composite bodies. And so if we have a shape that consists of different parts that of different parts, and we know the weight, and we know the centroid, that the centroid of composite body can be determined. So this one is on. This is for two. So we studied the ones in 2D on page of which one? We have studied the cases on page 53 on the. We have studied the case on 2D bodies on page 53. So here on this page, we are just doing the same thing on 3D bodies. So if you have problems, you have problems on these shapes that on these equations, go to page 53 and check those for 2D. Okay. And I have a example to explain how these work. So we have a steel machine element. This is this L-shaped thing here, and we want to determine the center of gravity, or you can just say the centroid of this L-shaped element. This element here means 元件. And the diameter of each hole is 20 millimeter. The diameter of each hole is 20 millimeter. And just let you know, for the shape of this element is looks like this. If we have it on the XY plane, it looks like this. If we look at it from this side, it looks like this. Oh, sorry. I should write like this. I think I have. Sorry, this is 40 millimeter, not 45. So from the side view, if you look at this shape from this to the negative z direction, you will get something like this. Is that clear? So these are the holes here, and these are the holes here. So this is. Sorry, this should not be a broken line. Sorry, this is this one should be a solid line like this. So you look at from towards the negative z direction, and these are the two holes, and we have a circular arc like this one. And take your time to draw this, and I assume you'll learn how to draw this in engineering drawing next semester. Now, how to do this? For this shape, this shape consists of 1 plus 2 minus the 2 holes. It is equal to this place plus this 1/4 of the circle, 1/4 of the circle, and then minus 2 holes here. And you know how to calculate the volumes of this shape, right? You know how to calculate this volume of this shape and the centroid of this shape that you also know. So the only trick here, the only thing here is that these two are removed materials. These are for these two holes, they remove materials. So I usually do it like this, and I would say 1 plus 2 plus 3 plus 4. And for these two shapes, the volume of these two shapes will be smaller than 0. That is we add the negative volume to. Sorry, I'll write it bigger. I add negative volume to these two shapes. I add negative volumes to these two shapes. And when we calculate the centroid of this shape, we usually draw a table like this. And because these volumes, we say because we remove materials, the volume will be smaller than 0. So please mark negative signs here first. Mark negative signs here first. So we have here. You say okay. Put negative signs here first, and you will then calculate everything right. Here, that's I will put in some numbers, and you do the rest. Okay. Let me put in some numbers here. I'm sorry. So the centroid of these four parts can be determined from the figure. From the equation, we know that it is equal to x bar is equal to summation xi vi divided by summation vi. This is the total volume of the shape, and this one is the summation of centroid and volume of each part. So because we did this, so we calculate the x bar and v of each part. for here, and this is the same for y bar and z bar. So write it down first, and I will talk about the next key point. Oh, sorry. Let me move it. So this one is sorry. EI. This is the summation. EI here. The biggest problem in this type of question is you mix up negative sign and positive sign. So for example, if we calculate this one, y bar v. So if you look at the textbook, then it should be it is larger than 0. It is positive. So, but we have many negative sign here. So how can we get positive number from here? So the answer is, now we have written down b is smaller than 0. So y bar is smaller than 0 and b is smaller than 0. So this one is equal to minus b times minus 20. So this is 负负得正哈 minus b times minus 20 is larger than 0. So remember, mark put negative signs here first if you are removing material. So after all the calculations, you will get x bar is equal to 15.5 millimeter, and the same can be done for y bar and z bar, and you can go home and do the rest.